Find the deep water wave celerity, C0, in feet per second. In this problem, we are given that the wind velocity in the x direction is 20 miles per hour. The length of the fetch is 15 miles long, and the storm event lasts for a duration of 2 hours. We are also provided the depth of water, d. The deep water wave celerity, C0, equals the deep water wavelength, L0, divided by the deep water wave period, T0. The deep water wavelength, L0, equals g times t squared divided by 2 pi. The variable t refers to the deep water period, T0. Therefore, we can substitute in this value of L0 into our equation for the deep water wave celerity, C0. And after simplifying this equation by canceling out a T0 term, the deep water wave celerity, C0, equals g times T0 over 2 pi. Variable g represents the constant of gravitational acceleration and equals 32.16 feet per second squared. We can determine the deep water wave period, T0, by knowing the storm duration, wind speed, and fetch length of the storm. Of the three possible types of storms, we'll first check to see if the storm is limited by its fetch length. If it's not limited by fetch length, we'll check to see if the storm is limited by its duration. If the storm is not limited by fetch or duration, it is said to be a fully developed storm, or a fully arisen sea. To check for a fetch-limited storm, we'll bust out the deep water wave prediction nomograph for English units, and find the intersection for the lines corresponding to a wind speed of 20 miles per hour and a storm duration of 2 hours. Tracing downward from this intersection, we determine the storm requires a fetch of at least 6.4 miles to fully develop. Since the storm fetch is 15 miles long, this storm is not fetch limited. Next, we'll check to see if the storm is duration limited by identifying the intersection of the lines corresponding to a 20-mile-an-hour wind speed and a 15-mile-long fetch. This point corresponds to a duration of 3.6 hours. Since the storm only lasts 2 hours long, this is a duration-limited storm, and we must use a duration of 2 hours when determining the maximum wave characteristics. When using a 20-mile-an-hour wind speed and 2-hour storm duration, the wave period equals 2.8 seconds. Plugging this value in for T0, the deep water wave celerity equals 14.33 feet per second. Lastly, we need to confirm this is a deep water wave by checking the value of d over L, that it is greater or equal to 0.5. In this expression, variable d refers to the depth of water, which was provided in the problem statement as 65 feet. L0 equals g times t squared divided by 2 pi. Here, we are assuming a deep water wave condition. After plugging in g and t, the deep water wavelength equals 42.128 feet. And 65 feet divided by 42.128 feet is greater than 0.5. This confirms that the value we previously used for T0 and C0 are both legitimate, and C0 still equals 14.33 feet per second. When reviewing the possible solutions, the answer is C.